So we are going to start the chapter application of integration. One second. Application of integrals. And easiest sections, and this year there's only half of this chapter. Application of integration, there are two topics. One is area under simple curves. Simple curves में lines, circle, parabolas, ellipses, ये सब चीज आपने लास्ट ईयर जो पढ़ाई किया था कॉनिक सेशंस में. So you should know the basic formulas of all these things. The second section was area between curves. Second section was area between two curves. But this year this not in syllabus. Yeah, अभी syllabus में नहीं इस साल. These are the only two sections that you have to study. Very simple concept, very simple. मतलब there is nothing new, nothing new. The concept you have already studied, integration already you have discussed. That's all, nothing extra. Suppose this is your curve, y is equal to f of x, and आपको जैसे x is equal to a and x is equal to b, इन दोनों के बीच में ये कर्व के अंडर एरिया, दिस एरिया, इसके बीच में जो एरिया है, दिस मच एरिया अंडर द कर्व from x is equal to a to x is equal to b. That means area under the curve y is equal to f of x. This area. So it is nothing but it is integral a to b f of x or नहीं तो y dx. Y dx. This is the formula to find the area under the curve, because we already have studied this. In definite integral, I have told you the geometrical meaning of definite integral. It is the area under the curve. The same thing. So one of the application of the integrals is finding the area under the curves. So if the curve is like this, y is equal to f of x, and उस curve के under x is equal to a से लेके x is equal to b तक आपको area निकालना है, तो it is nothing but integral a to b y. Y is your function f of x. That is nothing but it is integral a to b, y is your f of x dx. That's only concept. There is no other concept in this chapter. And sometimes instead of giving y is equal to f of x, if they give the function is like this, say x is equal to g of y, उस फॉर्म में x is a function of y, उस फॉर्म में दिया, and आपको y is equal to c से लेके y is equal to d तक उसका बीच में एरिया निकालना है एंड वाई एक्सिस के बीच में. सो द फॉर्मूला विल बी इंटीग्रल सी टू डी एक्स डी वाई होगा. ये बहुत रेयर केस में हम यूज करते हैं इंटीग्रल सी टू डी. सो इधर एरिया अंडर द कर्व एक्स इज इक्वल टू फंक्शन ऑफ वाई फॉर्म में दिया, y कोऑर्डिनेट y इज इक्वल टू सी एंड y इज इक्वल टू डी के बीच में एंड y एक्सिस के बीच में ये शेडेड एरिया. सो दैट फॉर्मूला इज इंटीग्रल सी टू डी एक्स डी वाई, और इन अदर वर्ड्स इंटीग्रल सी टू डी एक्स इज योर फंक्शन g ऑफ y dy. So the difference is first case में function is given in terms of x, second case में function is given in terms of y. So this is the concept of area under the simple curve, very simple idea. And area between the two curves, I will simply tell you what it is. It is not in your syllabus, but still I want to tell you that. से आपके पास टू कर्व्स होगा, जैसे वन कर्व इज मान लीजिए लाइक दिस, सपोज दिस इज योर कर्व y इज इक्वल टू f1x, another curve y is or y2 is equal to f2x, two curves. So इन दोनों कर्व के बीच में जो एरिया, so इन दोनों कर्व के बीच में एरिया मतलब इधर आएगा, दिस इज द एरिया between the curves. This is the area between the, this is not in your syllabus but it is a very simple concept. एरिया बिटवीन द कर्व्स. सो एरिया बिटवीन द कर्व्स निकालना तो सबसे पहले हमें वो पॉइंट ऑफ इंटरसेक्शन चाहिए, जैसे इधर एक पॉइंट ऑफ इंटरसेक्शन, इधर एक पॉइंट ऑफ इंटरसेक्शन. देन so if you need the area between the curves, so what you have to find is you can find the area under this upper curve. So अपर कर्व के नीचे जो भी एरिया निकालना सो पूरा का पूरा आएगा, उसमें से लोअर कर्व का एरिया का नीचे, लोअर कर्व का नीचे का एरिया सब्ट्रैक्ट कर देना तो आपको एरिया. सो अपर कर्व अप, सो दिस इज ए टू बी, सो क्या कर देना, यू हैव टू फाइंड इंटीग्रल ए टू बी अपर कर्व f1x dx. उसमें सो अपर कर्व का एरिया, अपर कर्व का नीचे का एरिया निकालेंगे तो आपको जस्ट टेल यू इफ इट इज लाइक दिस एंड यू विल गेट दिस कंप्लीट एरिया, पूरा का पूरा एरिया मिल जाएगा. इतना एरिया आएगा अपर कर्व का नीचे, उसमें से आपको लोअर कर्व का नीचे का एरिया, दैट इज इंटीग्रल ए टू बी लोअर कर्व, दैट इज लोअर कर्व वाज f2. लोअर कर्व में एरिया आएगा इतना एरिया, दिस इज द एरिया विच कम्स अंडर द लोअर कर्व, दिस कलर, और सब्ट्रैक्ट कर देना. सो अपर कर्व का जो अंडर आ रहे एरिया, उसमें से जो लोअर कर्व का जो अंडर आ रहे एरिया सब्ट्रैक्ट करेंगे तो आपको एरिया बिटवीन द कर्व्स मिल जाएगा. और इन अदर वर्ड इज सिंपली इंटीग्रल ए टू बी, साथ में लिख सकते हैं f1x माइनस f2x dx, और इन अदर वर्ड्स इट इज सिंपली इंटीग्रल ए टू बी. सो आपको सबसे पहले पॉइंट ऑफ इंटरसेक्शन निकालना पड़ेगा, देन अपर कर्व माइनस lower curve dx. So only these are the three concepts, and second one was the biggest section. Many problems was there, but anyway this year that is avoided from the topic, so that section is not there. But it is very simple only. It is area between the curves, it is area under the upper curve minus area under the lower curve in between the point of intersection. But anyway that will not come in the exam. So this is the two things. It is nothing but definite integral का application ही है. It is area under the simple curves, integral a to b f of x dx. So now we will go to the problems directly. And for the prerequisites for this chapter is you should know the simple formulas of ellipse, parabola, circles, and all those things. Last year we have discussed that. Now see, find the area of the region, question number 1. Find the area of the region bounded by the curve y square is equal to x. So इसमें से जो रफ फिगर ड्रॉ करना सबसे इम्पोर्टेंट है. So y square is equal to x. Y square is equal to x. That is a parabola. And what type of parabola it is? Open up or down, right or left? What type of parabola it is?
Upward.
See, you have studied 4 different types like upward, then rough picture only, downwards, then parabola open right, then parabola open left. In all the case vertices at the origin. In all the case vertices at the origin. So if it is upward, it is x square is equal to 4ay. Downwards, x square is equal to minus 4ay. Right side, it is y square is equal to 4ax. Left side, y square is equal to minus 4ax. In all the case, vertices is at the origin 0, 0. If it is at h comma k में vertices आएंगे तो वो केस इधर नहीं आएगा. You have to replace x with x minus h, y with y minus k. So that will not come here. So anyway, this is a basic formula. So y square is equal to x. So y square is equal to x. It is parabola opens right. So rough picture only needed. So it is a parabola which is open towards the right side. So this is your y square is equal to x. So you should know this because the graphing part, drawing the rough picture has almost 1.5 2 marks. Now find the area of the region bounded by the curve y square is equal to x and the lines x is equal to 1. X is equal to 1 matlab what type of line it is? X is equal to 1.
Parallel to y-axis.
No, x is equal to 1 is always parallel to y-axis, vertical line. So x is equal to 1 and x is equal to 4. So these are the 2 lines. X is equal to 1, x is equal to 4. So find the area of the region bounded by the curve y square is equal to x and the line x is equal to 1, x is equal to 4 and the x-axis. This is the x-axis in the first quadrant. So first quadrant में तो हमें चाहिए only this much area. This is the area we need. So this point is 1 here. This point is 1. This point is 4. So a required area is equal to integral 1 to 4 y dx. Your function is y is equal to f of x form में है. This is your function. So integral 1 to 4 y dx. So here y square is equal to x. So y should be root x. प्लस और माइनस रूट एक्स आएगा. ऊपर का पार्ट रूट एक्स, नीचे का पार्ट माइनस रूट एक्स आएगा. सो दिस इज इंटीग्रल 1 to 4 root x dx, which is integral 1 to 4 root x मतलब x to the power 1 by 2. X to the power 1 by 2 integral is x to the power x to the power n integral is x to the power n plus 1 by n plus 1. So x to the power 1 by 2 plus 1. 3 by 2 by 3 by 2. Definite integral है, so limit दे देना 1 to 4. So if you want that divided by 3 by 2, that is 2 by 3, you can take it outside, is common. X to the power 3 by 2, 1 to 4. So which is 2 by 3 into definite integral apply करने का technique है upper limit. So x को 4 दे देना 4 to the power 3 by 2 minus 1 to the power lower limit दे देना, which is 2 by 3 into a to the power m by n. A to the power m by n मतलब it is actually nth root of a the whole to the power m. So here 2 second root of 4 मतलब square root of 4. Square root of 4 is 2 उसका cube, so it is 8 minus this is square root of 1. Square root of 1 is 1, 1 का cube 1. 8 minus 1, so 8 minus 1 is 7. 7 into 2 by 3, that is 14 by 3. So it is area, so it is that much square unit. So these kind of simple questions will only come for your exam. Area under simple curves. It is nothing but it is the definite integral. So here integral 1 to 4 y dx. So कभी डायरेक्ट y का फॉर्म में नहीं होगा, इधर y स्क्वायर इज इक्वल टू x द कर्व का इक्वेशन, उसमें से हमें y का एक्सप्रेशन चाहिए था. So y is equal to root x, so that is why we wrote root x there. Then simple इंटीग्रेशन किया, so लिमिट अप्लाई किया. So always definite integral अप्लाई करने के टाइम upper limit minus lower limit, that is known as the fundamental theorem of integral calculus. उसका प्रूफ और आपको पढ़ाई करने की कोई जरूरत नहीं, just रिजल्ट समझ लेना. So we got the answer as 14/3 square units. Clear? Same next question is also the same type, so I don't want to repeat that. Same thing only, y square is equal to 9x, same. So I'm not going to repeat that. Look at the third question. Find the area of the region bounded by x square is equal to 4y. So x square is equal to 4y, it is again, it is parabola. So it should be something. Parabola, it is opens up. So rough picture, don't worry, x square is equal to 4y. Then y is equal to 2. Y is equal to 2 is the horizontal line. Y is equal to 2 and y is equal to 4. So this is y is equal to 2, y is equal to 4. And between y-axis, so this is your y-axis. So the area between these for y-axis, the curve, and y is equal to 2 and y is equal to 4, this is the area. So here we can use, so this point is 2, this point is 4. So we can say integral 2 to 4. So x is given in terms of y, so we can say x dy, 2 to 4 x dy. So x square is equal to 4y, so x is equal to 2 root y. So integral, so required area is equal to integral 2 to 4 2 root y into dy. So 2 can be take outside. Y is root y मतलब y to the power 1 by 2. Y to the power 1 by 2 का integral y to the power 3 by 2 by 3 by 2 2 to 4. और 3 by divided by 3 by 2 पर जाएगा 2 by 3 आएगा, that is 4 by 3. Then upper limit दे देना y to 4 to the power 3 by 2 minus 2 to the power 3/2. So which is 4/3 into 4 to the power 3/2, मतलब square root of 4 the whole cube. Square root of 4 is 2, 2 cube is 8, minus square root of 2 the whole cube. So which is 4/3 into 8 minus 2 root. So it is multiply करेंगे तो 8 into 4 32 minus 4 into 2 8 root 2 divided by 3, that much square unit. That is the area. That's the required area. That's the area bounded by the curve, these two lines, y is equal to 2 and y is equal to 4, and the y-axis. Clear? Next question. Find the area of the region bounded by the ellipse. So two types of ellipse हमने discuss किया था. One is major axis horizontal, another one is major axis vertical. And what about this? Major axis horizontal or vertical? X square by 16 plus y square by 9 is equal to 1. Major axis horizontal है क्या, vertical है क्या? How can you identify? You just tell me. It's very simple
Vertical.
question. Major axis vertical. How we are checking? We have to check the denominator, which is having the biggest denominator. So x square is having the biggest denominator, na? X square by a square plus y square by b square is equal to 1. Always हमारा assumption है कि ellipse का case में a is greater than b. So this is major axis horizontal. That means ellipse will be like this kind of ellipse. Then we have seen x square by b square plus y square by a square is equal to 1. So that is major axis vertical. Okay. So here major axis horizontal. So your ellipse will be like this. This is the ellipse. Then find the area of the region bounded by the ellipse. So a square is equal to 16. So a is equal to 4. So major axial length, semi-major axial length 4a. That means this point is 4, 0. Here the point is minus 4, 0. B square is equal to 9. So B is equal to 3. So this point is 0, 3. This point is 0, minus 3. Anyway, we have to find the area of the region bounded by the ellipse. That means we have to, means full area, inside full area we have to find it out. So that means we have to find the full area. This area you have to need. So कैसे करेंगे? You can find the area of one of the sector. Like if I give name like this, say O, A, B. So I can say required area is equal to required area is equal to 4 into area of OAB. क्योंकि ellipse is symmetric with respect to x and y axis. So एक क्वाड्रेंट का जो एरिया निकाल के 4 से मल्टीप्लाई करेंगे तो आपको पूरा एरिया मिल जाएगा. So now, so that means 4 into integral OAB का एरिया 0 से 4 तक. This point is 0 इधर. This is 4 क्योंकि मेजर एक्सिस का सेमी मेजर एक्सिस का लेंथ 4 था. So that point is 4, so that means that point is 4. So उतना तक एरिया अंडर द कर्व y dx. बट इधर एक प्रॉब्लम है कि y का फॉर्मेट डायरेक्ट नहीं है. ऐसे है कि x स्क्वायर बाई 16 प्लस y स्क्वायर बाई 9 इज इक्वल टू 1 ऐसे है. तो इसमें से हमें y का वैल्यू निकालना. तो इसमें से y स्क्वायर बाई 9 इज इक्वल टू 1 माइनस x स्क्वायर बाई 16, और इन अदर वर्ड्स विच इज 16 माइनस x स्क्वायर बाई 16. और आपको मिलेगा y स्क्वायर इज इक्वल टू क्रॉस मल्टीप्लाई करना. सो 9, सो 9 बाई 16 इंटू 16 बाई एक्स स्क्वायर. और यू कैन से y इज इक्वल टू प्लस और माइनस आएगा, स्क्वायर रूट निकालना 3/4 अंडर रूट 16 माइनस एक्स स्क्वायर. सो जो एक्स एक्स के ऊपर है y का वैल्यू पॉजिटिव होगा, एक्स एक्स के नीचे है y का वैल्यू नेगेटिव होगा. सो हियर यू कैन से 4 इंटू इंटीग्रल 0 to 4 y is 3/4 into under root 16 minus x square dx. That's all. Now 3/4 बाहर आएगा, 4 कट हो जाएगा, so बाकी 3 है. Then remaining is integral under root a square minus x square dx. So integral a square minus x square का फॉर्मूला क्या था? x by 2 into, this is the last set of 3 में आएगा, x by 2 into under root that same question a square minus x square plus a square by 2 sine inverse x by a. This was the formula. So you should by heart that formula. Without that it is not possible. So x by 2 into, so x by 2 into a square minus x square, the same question 16 minus x square plus a square by 2, that is 16 by 2 into sine inverse x by a square is 16, a is equal to 4. हो गया. अभी upper limit, so 0 to 4. So now upper limit minus lower limit दे देना. So that is 3 already बाहर है, upper limit दे दो. So upper limit 4 दे देना. 4 दे देंगे तो फर्स्ट टाइम में इधर 4 स्क्वायर 16, 16 माइनस 16 0 आ जाएगा, सो वो टाइम 0 हो जाएगा प्लस, सो 0 प्लस इधर 4/4 1 आएगा, साइन इनवर्स 1, सो 16/2 इज 8, साइन इनवर्स 1 आएगा माइनस, सो अपर लिमिट पूरा दे दिया, अभी लोअर लिमिट दे देना. लोअर लिमिट 0, सो 0/2 0, 0 इंटू एनीथिंग 0 हो जाएगा. सो फर्स्ट टाइम अगेन 0 अगेन प्लस इधर 0/4 0, साइन इनवर्स 0 इज 0, सो इट इज 0 ओनली. सो 0 प्लस आपको 0 ही मिलेगा. सो आपको आंसर मिलेगा 3 into 8, that it is 3 into 8 24 sin inverse 1. Sin inverse 1 is pi/2 because sin pi/2 is 1, sin 90 is 1. Yes, any problem there? A square by 2 किसने आरो यूज किया? If you want to say something, (24 into pi/2) that is 12 pi, that much square units. So So the area is equal to 12 pi square units, 12 pi square units. And I can tell you that formula, this formula of an ellipse always, the formula is pi AB. This is the formula to find the area of ellipse. Okay, pi AB. So either pi A ka value 4 the, B ka value 12 the, so it is 12 pi. But we are not supposed to use the formula. We have to use that concept of integration or application of integration. आया समझ में? Did you understand?
Yes, sir.
Okay.
Yes, sir.
Only this is the, yeah, this is the concept in this chapter. So tomorrow means in the next class we will do some more questions of this type. Then we will move to the next chapter because the main section was the second section, area between the curves. Lot of problems was there, but this year it is avoided, so you don't have to go through that. So we have to only find the area under the simple curves like this: ellipse, parabola, and straight lines. And in between this, maybe in between, okay, that also will not be there. So if only these things, area under the simple curves, and it's not a big thing. It's a very easy thing. So in the next class, we'll do one more question, few more questions, and then we'll move to the next chapter. Okay, see you in the next class then. Attendance based then. All right. Take care.